All right, we're going to finish up section 1-2, so that's why I called it 1-2b. And so the last thing we did was order of operations, right? The PEMDAS, please excuse my dear Aunt Sally, or parentheses, exponents, multiplication, division, addition, subtraction. Okay. Let's talk about what terms are. Terms. The definition the book says, I'm not going to write it down, but I'll just read it to you. It says it's an algebraic expression separated by a plus or a minus sign. So an algebraic expression, like if you just had the letter A, you could consider that to be an algebraic expression. Even a number could be considered an algebraic expression, all right? But then we're going to start seeing stuff like this. That right there, that whole thing, there's no plus or minus in between, correct? So that's one term. So this is one term, one term, one term. You're like, Mr. Hamrick, there's like three things there. There's an x, a y, and a squared. But that's still considered one term because it's not being separated by a plus or a minus sign. Make sense? We have a fancy name for that. We call it a monomial. You ever hear that? Why mono? Because mono means one. All right, so monomial, it means one term. Even though there's three different things here, that's still considered one term. What if you had something like this? What if you had 3x plus 1? What is that thing? Okay, technically it is a polynomial, but more specifically, if this is a monomial with one term, how many terms does this have? It's got two terms. What are the terms? The 3x and the 1. Now that's got three things, that's got three things. Why is that a monomial and that's a oh, I gave it away. What's two terms? A binomial. Why has that got two terms and that's just one term? The plus, right, because the plus in between, okay? The plus, or if it was a minus, that would separate the terms, okay? So that's one term, that's a second term. So when you have two terms, what do we call that? A binomial. Okay, bi meaning two, like a bicycle, right? Two wheels. That's a binomial. And of course, if you had three, that'd be easy. What's that? I'm not going to write it down. What if you had three different terms? That'd be a trinomial. I will write it down. Let's say, I don't know, 5ab c cubed minus 2a squared bc to the fifth plus a b squared c. What if you had something like that? Okay, that would be what? Trinomial, because there's three terms. They're separated by a plus or a minus. This would be one term, that would be another one, that would be another one. And they're all different terms. Do you see that? They all have a, b, and c in it, but this one has 1a, 1b, and 3 c's. This one has 2 a's, 1 b, and 5 c's. This one has 1a, 2 b's, and 1 c. So they are completely different terms. What if I had this? What if I had minus 3ab squared c? What can you see about that? So this one and this one have the same exact letters and exponents, don't they? All right, it's got 1a, it's got 2 b's, and it's got 1 c. So what do we say when a term has the same letters and variables? Everything's the same except for maybe the number outside the front of it. We call it a what? A like term, right. So these would be like terms. All right, because they're the same. Now the number out in front's different. What's the number out in front of this ab squared c? It's a 1. What's the number out in front of this ab squared c? Okay, it's not just a 3, it's a what? Technically, it's a negative 3, isn't it? Okay, it's a negative 3 out front, all right? What do we call the number out front? That number right there and this number right there. We give that a name. And we'll refer to this quite often, so it's good that we're talking about this now. You know what we call that name? Starts with a C. O. Coefficient. Very good. Coefficient. All right, so the number out in front is the coefficient. So how would I add or subtract these numbers together? I got a 1 and a minus 3. Well, if I have the same term, I just add the coefficients, or subtract in this case, right? So what is 1 minus 3? 2. Negative 2. And then what's my term? A, b squared, c. Everybody see that? So I don't really do anything with the a's, with the b squareds, or with the c's. All I do is just add the coefficient, and then you just keep the term right next to it. That's a basic Algebra 1 concept. Do you remember that? Sure. For instance, let's make that even easier, just to show you what you've done before. So what if I had like 5x squared plus 2x squared y minus 3x squared plus x squared y. What if I had something like that? It looks like I got 4 terms here, doesn't it? But really, I need to simplify it to find out how many terms I really have. I got a 5x squared. Do I have any other 5x, or not just 5, I shouldn't say 5. Do I have any other x squared terms? You're like, well, yeah, that's got an x squared in it, but this one's got an x squared and a what? And a y. Is this the same term as this? No, it's not. Where is the same term as the other x squared? The minus 3x squared. Very good. So I got 5x squared minus 3x squared. I don't really do anything with the x squared. All I do is add or subtract the coefficients. So it's 5 minus 3, which is 2. No, it's positive. It's positive 5 minus 3, which is positive 2x squared. Now, if I had a long string of these things, if I had a whole bunch of these, a lot of times I like to mark them off so I know I'm done with them. I only got 4 here, so it's not that big of a deal. But sometimes you might have like 6, 7, 8 things that you have to add up, right? 6 or 7, yeah, okay, I get it, whatever. So stupid. I've never even seen one of these videos. I just know it from you guys. The last class, well, my first class today, they were talking about these. Mr. Henry, do this when you say 6 or 7. I'm like, I don't know. Is that like a bad thing or just a dumb thing? It doesn't mean anything bad, right? So if I say that, okay, I've never seen it. I'm not on TikTok or whatever. Is that what you see it on TikTok? Okay. Anyway. Maybe because I put a filter on there. Don't show me dumb stuff. So maybe that's why I don't see that, because, just kidding. All right, here we go. Do we have any other like terms? Yeah. X squared y, x squared y. There's 2 of them here. How many here? There's 1. Add them up. Plus 3x squared y. So really, this thing right here, when I simplified it, gave me a what? A binomial. All right, enough of that. All right, let's talk about substitution. I've got a big, long definition for it, but I think you guys understand what it means to do substitution. I'll give you a super little example. So I'm going to give you, they use this word a lot, evaluate. All right, evaluate, or tell me what the answer is what they're really saying. All right, evaluate, I'll just make up an easy one, 2x if, now if I just said evaluate 2x, there's nothing you could do with it. I can't figure out what that number is equal to unless I knew what? What x is. If I knew what x was, then I could figure out what that answer is. So that's what they tell you. They tell you what x is. So they say if x is equal to, I don't know, let's make it negative 3. So this is substitution. So evaluate 2x if x is equal to negative 3. So what is that 2 and that x? What are they doing to each other? What operation are they doing? It's multiplication, right. When they're just next to each other, it just means multiplication. So it means 2 times what? X. What is x? They say it's negative 3, and then you just do the work, and it's negative 6. Very simple. I can't think of really any other substitution that's any easier than that. Maybe a plus. I could have put x plus 2 or something like that. That might have been a little easier. I don't know. But that's pretty simple. Would you agree? All right, let's do a few examples. Let's see what else I have after this. Okay, then we're going to do something that's kind of the same but a little different. So this is example 4. If you look in the book, it's example 4. And they say evaluate the following things. I'm going to give you 4 different problems we're going to evaluate. All right? So evaluate if x is equal to 2, y is equal to negative 3, and z is 1/4. All right? And what are you going to evaluate? Well, let's do a first. It's x squared plus y minus z. Tell you what, I will give you 90 seconds to come up with an answer. And go. You're on the clock. What? Oh, you already got it already? Did you say 34? Oh, I thought you said 34. No calculators. What are you doing? Did I ask yet? Everybody get an answer? All right, I'll stop my timer. All right, so what'd you do? You went 2 squared, correct? Plus, well, did you have to put plus negative 3? You could have just put minus 3, couldn't you? In the same thing? Yeah. And then minus z, which is what? 1/4. What do we do first? Order of operations, exponents first. So that's 4. Let's do it in our head. 4 minus 3 is 1 minus 1/4. Okay, so you could just do it in your head. Hopefully you can. If I have one whole thing and I take away 1/4 of it, how much do I have left? I got 3/4. Or you could have changed this to 4/4, couldn't you? Right, common denominator. All right, and then go 4 minus 1 is 3/4. There you go. All right, super easy. I don't think I'm going to do all 4 of these. Let's do... Let's do this one. This is actually C in the book. All right, so it's 2x squared plus 3y cubed. Since you guys are so smart with that one, I'll give you 60 seconds on this one. Go. Write it down. Don't do it in your head. I want you to write it down. You should always get used to writing things down. Sure, you might be able to do it in your head, all right, and that's fine. That's good. I'm not saying that's a bad thing to do it in your head, but you need to get used to writing all your steps down because you're going to have problems. There are going to be a lot more steps than this, and you need to be in that habit of writing down all your steps. It's 2x squared plus 3y, and the whole thing is cubed. This thing, I crossed out the b because this is example C. You have 20 seconds left. You have 5 seconds left. Anybody get an answer yet? Yeah? Oh, there's my thing. So what'd you get? Anybody? -1? What? You're right. -1 is correct. All right. So here we go. Let's watch. A couple things right here are pretty important to do. So we've got a 2 times an x squared. Now watch this. Everybody watch. When you're squaring something or cubing it, take it to any power. I would always put it in parentheses. So what is the x? Now in this case, it wouldn't matter. But if it was a negative, it would matter. So just in case, I always put it in parentheses to make sure. So this is 2 what? Squared plus 3 times y, which is -3. All right? And that whole thing is being what? cubed. All right? We can do a little bit of this in our head. 2 squared is 4 times 2 is 8. Let's do this. It's just 3 times negative 3. What's that? Negative what? 3 times 3? Yes, negative 9. I was thinking 3 cubed because of that cubed right there. You're right. 3 times negative 3 is negative 9. And then that is being what? Cubed. What's 8 minus 9? Negative 1. And make sure you put that in parentheses. Again, in this situation, the parentheses really wouldn't make any difference. But if this was an even power, if it was squared to the 4th to the 6th, that would make a difference. So we do this all the time just to make sure that we're careful and we don't forget. So what is negative 1 to the 3rd power? It's negative 1. Now, how do we do that, though? A lot of people might look at it as, oh, it's just a negative out front and 1 cubed. 1 cubed is 1, then a negative out front. It's the same answer, but that's not really how you get to it. How do you get to this answer? You're actually taking negative 1, multiplying it by itself 3 times. So you're saying this. Negative 1 times negative 1 is positive 1, times another negative 1 is negative 1. So that's how you want to look at that. All right, we good? All right, let's do another one. This is D. I'll put it here. So it is... all right, yeah, let's do this one because the 1 minus 1/4 getting 3/4, yeah, you can do that in your head. This next one's a little trickier. Not a whole lot, but a little bit. So you got to know how to do fractions. And I want you to do this stuff without a calculator. No calculators. What do you mean side by side? No, I want you always, anytime you write a fraction, listen, get out of this habit. Stop doing that, all right? Because that's going to mess you up. It's going to confuse you. I'm not saying the answer is 1/2. I'm just using a fraction as an example, okay? Write your fractions like this because when you start working with them, especially multiplying them together, dividing them, adding and subtracting, okay? Anything you do, you want to work with it looking like this. Don't do the slashy thing right there. If you want to write your answer like that, I guess it's okay. But when you're working with it, you should have a numerator on top. You should have a denominator on the bottom. And that'll save you a lot of heartbreak from getting problems wrong. Scroll up. Oh, to see the X, Y, and Z's. Sorry about that. You didn't write that on your paper before? X is 2, Y is negative 3, Z is 1/4. I'll put it right here so you can see it. X is 2, Y is negative 3, Z is 1/4. There we go. Oh, I didn't set the timer. I'll give you 30 seconds from now. Well, I already gave you a minute before I started the timer. You can leave it improper, it's fine. Oh, time's up. Yes. All right, here we go. When's this class over, by the way? 25? Okay. Yeah, I need a few minutes to do the next couple examples, so let's go through this. So it's 2 times x plus y, so that's 2 plus negative 3, or 2 minus 3. It's the same thing, isn't it? Minus y, which is negative 3, times z, which is 1/4, plus z squared, which is 1/4 squared. Everybody should got that, right? Yep, just plug everything in. Yep. So that's negative 1 times 2. 2 times negative 1 is what? Negative 2. What's that? That's positive, right? So that's going to be a plus. What's 3 times 1/4? 3/4. Yeah, that was easy. And then this isn't so hard. 1/4 squared. 1/4 times 1/4 is 1/16. All right. Here's where, even though you've done this since you were in, I don't know, when did you do fractions? 3rd grade maybe? I think 3rd, 4th grade probably you learned how to do fractions. You got to find a common denominator. So what would your common denominator be? This is over 1. I got a 1, a 4, and a 16. 16, right. Everything divides evenly into 16, so I'm going to write this as 16. I'm going to write this as 16, and this. There's other ways you could do this. This is how I would do it, okay? So I'm just showing you. Now, you have to ask yourself, 1 times what? What did I multiply 1 by in order to get 16? 16. So I multiply the top by 16. So what's 16 times -2? Negative 32. 4 times what is 16? 4 times 4. So what do we multiply the 3 by? 4, which is 12. Right here, 16 times 1. Didn't have to change that, so I keep that a 1.
Wait, I think I got it.
Okay. So what do you get here? What's that? -20, right? Plus 1. What's -20 plus 1? -19 over 16. And there you go. That's your answer. All right. So the only thing hard about that was not the substitution. It's just the fractions, because we forget how to do fractions all the time. Probably because you're using this little thing to do your fractions. I don't know, maybe. Let's learn how to do those fractions without a calculator. All right. Last example, but I got 2 parts to it. So if I looked on my phone for the temperature today, I go to my AccuWeather, and it says it is 68 degrees, right? It's nice temperature, 68 degrees. But it says 68 degrees, and underneath of it, it's got a little letter. What do you think that letter is? Fahrenheit. It's Fahrenheit, okay? So it says in Fahrenheit. Let me ask my Spanish friends. You guys don't use Fahrenheit, do you? What do you guys use? Celsius. The whole world uses Celsius except for us. Okay, we're the only ones. I guess it's Americans just being Americans. I don't care what the rest of the world does. We're going to do it this way. Maybe that's the reason. I don't know. We should have converted to the metric system long time ago. I guess Celsius is considered metric, yeah, because it's by 100. But it makes more sense. I mean, look. Americans, what is the freezing temperature of water? 32. What's the boiling temperature of water? 212. What stupid numbers? Whoever came up with that, I don't know. What is freezing temperature in Celsius? 0. That makes sense, doesn't it? 0 freezes, okay? What's boiling? 100. That makes sense, right? 0 and 100. Wouldn't that be a lot easier? But that's not what we use, okay? So what do we have to do? We have to convert. All right, now, you could very easily convert. You got ChatGPT, you got Google, you could talk into your phone, you got Siri and everything else, and you could just say, what is 68 degrees Fahrenheit in Celsius? And boom, it'll tell you. Back in the day, we didn't have that. I remember, this is my quick little story. I was standing in line at college for lunch, and I had a friend of mine, he was Korean. He lived in Korea, he was wasn't an exchange student, because in college you don't really call them exchange students. But he's from Korea, and we said something about the temperature, and I said it's whatever it is, 68 degrees, right? He had a little watch with a calculator on his watch, right? And he knew the conversion. He knew how to convert. This is before the internet, before anybody would tell you. He knew what the formula was, and he typed it on his phone. Oh, that is, boom, whatever 68 degrees is. So what could I do on my phone? I could just say, what is 68 degrees Fahrenheit in Celsius? And then, boom, it's 20. I think it is. Yep. Oh. There we go. All right. And, yeah, it's 20 degrees Celsius. All right. So it's that easy. But he was able to do it on his watch. He had a little tiny calculator. He went, doot, 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 like this. on his phone. Or not his phone. We didn't have phones like that back then. But what did he do? Well, I'm glad you asked. So he used this formula. Write this formula down. If you want to convert something to Celsius, this is the formula that you're going to use. See, if we all just use Celsius, we wouldn't have to worry about these dumb conversions. Wouldn't you agree? Yeah, the metric system's the same way. It's so much easier. Everything's in tens, right? Everything is multiple of tens, but not in our system. Well, it's not our system. Blame the English. It's called the English system or the imperial system. And, think about it. There's 12 inches in a foot, right? And there's 3 feet in a yard. And there's, 5,280 feet in a mile. All these numbers you got to memorize. Like how many cups and pints and all that stuff. I still have problems remembering that thing. But if you just remember the metric system with all the millas and the kilos and all that kind of stuff, it's so much easier because everything is just by tens. So anyway, talk to our president. Maybe he'll convert us to the metric system. And everybody's like, oh, I don't want to go to the metric system. But you use it already, like your sodas. If you have a soda in the fridge, what size is it usually? It's a 2 liter, right? So we know what 2 liters are. You go to 7-Eleven or Wawa, you can pick out a 1 liter bottle. You kind of know how big a 1 liter bottle is, don't you? So we're used to that kind of stuff. Why we don't completely convert over, I don't know. It's beyond me. All right, that's my rant. That's my metric versus imperial system rant. I wish we would go to the metric system, but I don't think we ever will. All right, so here we go. And we got another formula, is this. This is the inverse of what we just did. If you look at it, do you see any similarities? Look, the 5/9 and the 9/5, the minus 32 and the plus 32. All right, so if you memorize one, the other one you kind of can remember it. All right, it's memorizing the one is the hardest part to remember. But this guy, he knew, right? Jae-hong Kwak was his name, Jae-hong Kwak. And his dad was the vice mayor of Seoul, Korea at the time. So he was like a bigwig. I taught him how to drive. Isn't that cool? So anyway, he didn't drive because he always had people. His dad was always this uppity up in the government. And so he always had drivers all the time. He lived in this big fancy apartment building, real nice apartment building. He showed me a picture. And he would come down, he'd have a driver, take him to school, and all that kind of stuff. He didn't have to learn how to drive. And plus you're in Seoul, the public transit system's way better than anywhere else. So anyway, I taught him how to drive. Jae-hong, I don't know what he wanted to cure cancer. That was his goal in life. And I should look him up. I have looked him up and I couldn't find him. But anyway, here we go. What does the C stand for? Celsius. The F is Fahrenheit. So let's do one. Let's go 68 degrees. We used that already. Let's put the 68 in here. I don't have that in my notes, so we'll have to figure it out. So Celsius, we want to find out what it is in Celsius. All right, so we go 5/9 times, it's supposed to be a 9, the Fahrenheit minus the 32. So it's 68 minus 32. Here's one way to kind of figure it out a little bit easier. 5/9 is really close to 5/10, isn't it? What's 5/10? It's a half. So if you just subtract 32 from your temperature, your Fahrenheit temperature, then take half of it, you're pretty close to what it is in Celsius. It may not be exactly, but it should be pretty close. So let's do that. 68 minus 32 is what? 36? Is that right? So 36. And then what's half of 36? It's 18, which is kind of close, right? It's kind of close to 20. But if we did this, what would we get? Oh, this works nice, doesn't it? 9 goes into that once. 9 goes into this 4 times. What's 5 times 4? It's 20, and there you go. So it's 20 degrees Celsius. So if somebody says, oh, it's 20 degrees outside. It feels great. What do we normally think? If somebody told us it's 20 degrees outside, it's freezing cold. It's way below freezing. It's way below 32. So 20 to us would sound, pretty cold. But anybody else in the world, you say it's 20 degrees, it's a pretty nice, pleasant day. Would you agree? Yeah. All right. And then you do the same thing with here. Give me a Celsius temperature where you think it might be? What do you think would be a hot summer day in Celsius? 32? All right, let's put 32 in here and see if it works. So 9/5, 32 plus 32. All right, so what's that? 64. Won't come out as pretty, but that's all right. 64. This time, I'll let you use a calculator on this. What's 9 times, let's see, I'll use my calculator. 9 times 64, 9 times 64, and then divided by 5. And that's 115 degrees. Wow, that'd be pretty hot. 115. Does it get to be 115 in Spain? Or does it get to be 32? Would you ever go outside and it's 32 degrees outside? Sometimes, maybe. So it does get that hot to 32? Wow. Well, it is Spain. I always think of Spain being hot like all the time, all year round. I don't know. That's just in my head. That's what I think. So that's 115 degrees Fahrenheit. Or we could do this. What's 9/5 pretty close to? An easy number that's pretty close to. 10/5, right? Which would be what? 2. So if I double it, I get 64. I'm sorry, if I add these up, I get 64. And if I double that, that's what? 128? It's not super close, but it's pretty hot, right? It's not super close to 115, but you get the idea. You could get a general idea of how hot by, if it's in Fahrenheit, take 32 away, and then take half of it. If they give it to you in Celsius, right, you want to figure out what it is in Fahrenheit, then you add a 32, double it, and you're kind of close, kind of. Not exactly, but kind of. We good with that? All right, it's pretty easy stuff. You just got to know the formulas, all right? So you got to know that formula, and you got to know that formula. So make sure that you learn those, because I might ask on a quiz or a test for you to do that. So let's do your homework. Have some of you guys already started on this? Because this is part B. And that's good. Pages 10 and 11. 1 to 35 odds. Is that what I gave you? All right. So there you go. So let's have that homework done for tomorrow. I'll collect it tomorrow, and then we'll start on 1-3 tomorrow. All right, that's it.